Okay, how about if we take a look at this? All right, now, there's a couple things I want to say about this. First of all, it's so important, and I know sometimes people they want to hurry and get things done, and so they don't do this, but in your notebooks, when you're doing these proofs, this is probably the hardest thing we do in geometry are, formal proofs like this. But it's important in math to be able to. Geometry is a great place to practice this skill, but proofs aren't just for geometry; they're for all kinds of math. It's an important part of math to be able to start with some given information and put together a deductive argument. So based on stuff that we know, can we demonstrate that if we know this given stuff, we can show that this statement that we're trying to prove has to be true. Okay? And one sort of fringe benefit of this is that in life, when you're trying to prove things in discussions, if you're debating a point, or if you're trying to demonstrate something, that this statement is not true, the skills you develop in math, here's where there's some direct crossover between the logic of math and the logic of real world stuff. If you're going to be a lawyer, you're going to want to be good at this kind of thinking, for example, because this is the deductive reasoning that you'd want to use in a courtroom to show that the statements you're making are true. Right? So it's that deductive logic is really useful. All right. But now we're talking geometry. So when you're doing these things, when you're writing these proofs, it's very helpful to write down the figure that you're working on. So this triangle up here with this vertical line drawn down from the vertex C, we got to write that in your notebook. And as we go through this thing, we can mark that up with congruences. All the stuff that we say in the proof, we can add with symbols to this picture, and then that picture starts to be really important to us. It starts to tell us a lot of stuff. Well, first of all, what about this given information? Side AC or segment AC is congruent to segment BC or side BC. That's given to us. How would we mark that on the picture? How do we say sides or segments are congruent? Yeah, little lines, right? Segment marks or segment congruence marks. So we'll say 1 mark, 1 mark. M is the midpoint of side AB or segment AB. Okay, well that's our first statement. So what's our reason going to be for that one? Given, yeah. And that's almost always the first reason. That's a freebie. Okay, now let's talk about, before we get into the specifics of the proof, let's talk about our strategy. If I want to show that triangle ACM is congruent to triangle BCM, so the left triangle and the right triangle are congruent, can you see some stuff that we could do? Before we jump into this real quick, what are the 4 congruence relationships that we have for a triangle? I'll start you off. SSS works. SAS works. What else works? Okay, AAS works. No, that's the one that doesn't work, right? We can say ASA, but the 2 that don't work, one of them is the bad word, right? ASS doesn't work, thankfully. And what's the other one that doesn't work? AAA, yeah.
You just called it.
So AAA doesn't work. And I'll write it backwards, how about? SSA doesn't work either. Okay? Those are the 4 congruent statements that work. So we got to find one of those that we can maybe get to work in here. Any suggestions what that one might be? Well, that's a possibility. Or AAS. I mean, those maybe.
If you look at the triangle, you have the points that might be congruent.
Okay.
You can get midpoint, which is the right angle.
Okay. Now, what parts can we add to these 2 triangles as being congruent? Well, there's one pretty easy one. Do they share a side? We always want to look for that. Yeah, they do. They share side CM, don't they? right? So then if they share that side, it's congruent to itself, so it works in both triangles. Now sometimes what's useful to do there is pull the triangles apart. This, with the triangles, it's not as necessary as it maybe will be later on, but copy that. I don't, sorry. So now what if I'm just going to draw this by hand, so it's not going to look very good, but what if I pull those two triangles apart? So there's my left triangle, A, C, M, and here's the right triangle. Right? Then sometimes it gets easier to see that, yeah, look at this. We've got this. We've got that shared side that's appearing in both triangles. Right? When you pull them apart, sometimes that helps. So when I do that, it means that now the triangles have been pushed back together, and that single congruent symbol, right, stands for both triangles. Okay? And you might be familiar with that already, but there we go. Okay? So we've made that statement. Now we have to add that to our proof somewhere. And we will. Okay, so what else could we do? What about that midpoint thing? That must be important. If M is the midpoint of AB, what is that telling us? Say it again. Yeah. Okay, and let's just, you're right. Let's just skip right. I know last time, we could get real technical and say then we got to break it up into two segments and add them up, but let's see if we can just jump right to a congruence relationship. If M is the midpoint, can you tell me two segments that would have to be congruent because of that? AM and MB, right? Okay, that makes sense. And that's because of M being the midpoint, the definition of what a midpoint is, right? So now where does that stuff fit into our proof? If we look down here at our steps, 3 is wide open. 2, I have a start of a reason for you. Definition of, what must that be? Well, the reflexive must be the other one, right? Definition of, what is that thing again? Midpoint, yeah. The definition of midpoint. In other words, what does a midpoint mean? Is that the two segments it creates are congruent, right? So what's the statement that's going to go with that definition of midpoint? Okay, good. Side AM, or segment AM, I should say, is congruent to segment MB. Now, how would I enter those in Moodle? Lawrence. There you go. Good, good. So we could do something like this. We could say instead something like segment AM all 240, right, is congruent to something like that. Or I could say side if I wanted to. That would work also, segment or side, right? And then you already told me that the other relationship here was this reflexive property one, right? So we already know the reason for that. You told me is going to be reflexive property for our third step. Reflexive property of congruence. And what was the statement that went with that? Why did we use that? Yeah, okay. Side or segment CM is not equal to, but congruent to itself, right? So we'd say something like CM, side CM is congruent to side CM. So, yes, sir.
And so what's the difference between the congruent symbol and the one with just the 3 lines?
Well, okay, in Moodle, that's the 3 lines.
That means congruent.
It means congruent in Moodle, yeah. Mm-hmm. And so in Moodle, then, if we wanted to write this step right here, we could say something like side, or segment. Side CM all 240 right? And now, what's our reason for being able to say that the triangles are congruent? Side, side, side. Good. And all we write there is just S, S, S. Okay? Okay, this is, and there's no, we've got to a point now in math, things are sophisticated enough and advanced enough that this is a good thing. That it's not just like maybe it used to be where you just get a formula and plug stuff in. You got to do some real innovative thinking on these proofs. Every proof is different from the others, right? You got to put the information together in a different way. Okay? Maybe we'll look at another one tomorrow, but let's see if we can get to a lab today and get some practice.
Dude, I was taking my chemistry test over here.